Alrighty, boys and girls, welcome to video lesson 3-2, our lesson on complex numbers. Complex numbers are imaginary numbers. Our learning target for 3-2 is I can add, subtract, multiply, divide, and simplify complex numbers. Alrighty, let's go. A complex number, an imaginary number in standard form is written a plus bi, where a is the real part and bi is the imaginary part. An example would be something like 3 plus 2i, or negative 4 minus I. 3 is the real part, 2i is the imaginary part. Here in this one, negative 4 is the real part, and negative I is the imaginary part. On your calculator, you can go to mode, and you can always work with imaginary numbers by changing your mode from real to the a plus bi mode, and we'll do that in class. Okay, we discovered this in class. There is a pattern to the exponential powers of imaginary numbers. You discovered that I to the 0 is 1. I to the first is I, or I to the first, the square root of negatory 1. I to the second is negative 1. I to the third is negative I. And I to the fourth goes back to 1. So every 4 powers, it has the pattern of going 1, I, neg 1, neg I, 1, I, neg 1, neg I. So I to the 8th would be back to 1. I to the 9th would be I, etc. So looking at these problems right here, I to the 124th power, I to the 124th power, 124 is a multiple of 4. 4 goes evenly into 124, so this is just kind of like I raised to the 4th power, or I to the 0 power, which of course is 1. I to the 41st power, well, 41. The biggest multiple of 4 that goes into 41 is 40, so we can think of this as like I to the 40th times I to the 1st. Well, I to the 40th is just 1, and I to the 1st is just I, so this equals I. And I to the 142, well, the biggest multiple of 4 that 142 has is 140, so we can think of this as like I to the 140 power times I to the second. Well, I to the 140th power is just 1 times I to the second. Well, I to the second is neg 1, so this answer is negatory 1. Okay, let's try this guy right here. We're going to FOIL this binomial times a binomial right here. So I'm going to start by doing 4 times 5, which of course is 20. 4 times positive 3i is plus 12i. Negative 5i times 5 is negative 25i. And negative 5i times 3i is negative 15i squared. Let's combine our like terms. We'll do that in green. 12i minus 25i is negative 13i. I still have a 20 out front. And now over here I have negative 15i squared. I squared, of course, is equal to neg 1. So I have minus a negative 15. Well, that minus minus, we know from our middle school days, becomes a smiley face, which is a plus. So minus minus becomes a plus. So I have 20 plus 15 is 35 minus 13i. And that is my answer in my complex number in standard form, where 35 is my real part and negative 13i is my imaginary component. Okay, you guys try this one on your own. Foil that out, get your answer, and write it in standard form. Okay, you should have found a final answer of 149. Let's go through that and see how we got that. Hopefully you noticed when you were multiplying, you had your 2 original binomials, or what we call conjugates. And these are our factors of a difference of squares. So our middle terms we're going to cancel. But when I FOILed, I got 10 times 10 is 100. 10 times 7i is 770i. Negative 7i times 10 is negative 70i. And neg 7i times 7i, of course, is negative 49i squared. our middle terms, 70i and negative 70i, they canceled out. And over here, I have I squared, which of course is negative 1. So what I had here is I have 100 minus negative 49. So this minus minus become a plus, and I have 100 plus 49, and my final answer of 149. Okay, let's try this guy right here. We have a negative 5 over 3i, and again, we have a 3i in the denominator of our fraction. We cannot have an I in the denominator of our fraction because our fraction rules say you cannot have a radical in the denominator of a fraction because I is equal to the square root of negative 1. You cannot have a radical in the denominator of a fraction, so we're going to rationalize by just simply multiplying the top and bottom both by I. Up top now, I get negative 5 times I is negative 5i. And on the bottom, I get 3 times I, which is 3i squared. Of course, 3i squared is 3 times negatory 1. So I have negative 5 times, negative 5i times negatory 3. My negatives are going to cancel and become a plus, and my final answer is 5i divided by 3, or 5i over 3. Okay, in this guy right here, we have a 15 divided by 11 minus 2i, and 11 minus 2i is in the denominator of our fraction. Once again, we see we have an I in the denominator of our fraction, so we need to rationalize. We're going to do that not simply by just multiplying by I, both top and bottom. That won't work. That ain't going to cut it. That won't do it. We need to multiply by what we call the conjugate of 11 minus 2i, which is 11 plus 2i. So we're going to multiply both top and bottom by 11 plus 2i. Okay, so up top now I'm going to distribute that 15. 15 times 11 is 165. And 15 times positive 2i, of course, is 30i. On the bottom, we're going to multiply 11 minus 2i times 11 plus 2i. These are conjugates, so I'm going to get 11 squared, which is 121, minus 2i squared, which is 2i times 2i, which is minus 4i squared. Up top, I have 165 plus 30i. And on the bottom now, I'm going to take my 4i squared and write that as negative 4 times negative 1, which of course is plus 4. 121 plus 4 is 125. I can now simplify. Both top and bottom by factoring out a 5. So I'm going to factor a 5 out of here. Okay, so this becomes 5. It goes into 165 33 times. So I have 5 times 33 plus 6i. Factor the 5 out of the 30i. On the bottom, I have 5 times 25 is 125. And these 5s can now cancel. So my final answer, and I'll write that in green up top here, is going to be 33 plus 60i over 25. Okay, and this guy right here, we are going to add some fractions. We're going to add some fractions. In order to do that, we need to get a common denominator. Our common denominator is going to be 2 plus I times 2 minus I. There's our common denominator, which means I need to multiply this fraction by 2 plus I, both top and bottom. And this one I need to multiply by 2 minus I, both top and bottom. Okay, you guys do that. You guys try that on your own. Simplify this fraction, and I shall be right back and go over it with you. Okay, you should have had a final answer of 12 plus 9i all over 5. Let's go through how we got that. Again, I got a common denominator, which is 2 plus I times 2 minus I. So I multiplied the left fraction by 2 minus I, both top and bottom. I multiplied the right fraction by 2 plus I, both top and bottom. So here, and I distributed my 2i, I got 4i minus 2i squared. And on this side, I distribute my 5, I get plus 10 plus 5i. On the bottom, I'm going to multiply 2 plus I times 2 minus I, which are conjugates, since it's a difference of squares. So I get 2 squared, 4, minus I squared, which is I squared. Up top now, I'm going to simp I have 4i plus 5i is 9i. Negative 2i squared, of course, is negative 2 times neg 1 plus 10 still. And 4 minus I squared is minus negative 1, which is plus 1, 4 plus 1. On the bottom, I get 5. And on the top here, I now have positive 2 plus 10, which is 12, plus my 9i. And there's my final answer. Alrighty, Dottie, for a bonus point. First 5 people to email me, you must email me your answer in simplest form of this expression. Your answer can be either a real number, an imaginary number, or a complex number in standard form. First 5 people to email me this answer get a bonus. Alright, folks, adios, and we shall see you mañana.